It started in South Africa towards the tail end of November. From there, it spread to Australia, then Austria. Austria was followed by Belgium and Botswana and Brazil. Canada, the Czech Republic, Denmark, France, Germany, Hong Kong, Israel, Italy, Japan, Netherlands, Nigeria, Norway, Portugal, South Africa, Saudi Arabia, Spain, the United Kingdom, and for me, probably the most sad of all, Sweden. Ladies and gentlemen, on today's episode, we're going to talk about the science behind Omicron-O.
Welcome to The Science Behind That with Atticus Hamilton.
Hello all you scientists out there, and welcome on back to The Science Behind That podcast. I'm your host, Atticus Hamilton, and as you heard from the intro, today we're going to be talking about the science of Omicron-O. Now, before all of you are like, Atticus, you have talked about SARS-CoV-2 way too much. You know, I don't disagree with you. I have talked about SARS-CoV-2 quite a bit. But this one, it strikes me as really important to talk about because it is everywhere. Not necessarily the virus, it's not here in the US yet, thankfully. Although my virology professors would have you believe otherwise. Nonetheless, it's more of every news source I saw in the past, 2 weeks, has just been reporting on Omicron non-stop. But very few people have actually stopped to explain what it is. So ladies and gentlemen, because it is kind of my job here on the internet to explain to you guys the science behind everyday life, I thought it was an obligation of mine to talk about this. So, before we jump into this, I want to invite all of you scientists listening to me right now to go grab yourself a steaming hot cup of coffee, add a little bit of maple syrup to it. Not too much, just enough to feel those nice fall flavors, autumn flavors, and that spiciness of the coffee, and sit down and join us for today's episode. So, where to begin? As a recap, for those of you who have not listened to my previous episodes, SARS-CoV-2 is in the family of viruses called coronaviruses, and they're called coronaviruses not because of the beer, but they're called coronaviruses because under an electron microscope, the virus looks like it's wearing a little crown. And just some, brief little biochemistry for you. They're positive sense single-stranded RNA viruses, and frankly, we're not going to dive into that too much today, but that is important because that is one of the things for why we have had so many different variants of this particular disease appearing. This particular virus is very large. Its genome is very large. It's about 22,000 base pairs. Now, compared to a human, right, which has 3 billion base pairs, that's not that much. But when you compare the size of SARS-CoV-2 to other RNA viruses, it's pretty big. And it is because of that we get a lot of mutations. So RNA viruses don't really have good proofreading mechanisms. And I'm going to spare you the complex biochemistry of that. But SARS-CoV-2 is nonetheless, is no different than its cousins. It doesn't really have a lot of good proofreading mechanisms. Now, it has some, but it is not able to identify every incorrect base pairing made within during replication. And so that, coupled with the nature of its genome and just the size of it, is why we've had so many of these strains appear. Now, ladies and gentlemen, the question I think that all of you guys are thinking is, first, why is it called Omicron? And this part of our talk today, I can't take 100% credit for. This was talked about by one of my professors in virology. Originally, it was going to be called SARS-CoV-2 new, because new follows Delta in the alphabet, in the Greek alphabet. But the people at in South Africa, where the strain was first identified, did not want to call it new because, well, people would think they're talking about a new coronavirus. And then following new, we have Xi, or XI, but they didn't want to call it XI, or Xi. I hope I'm pronouncing that right. Because that is a very common last name. So they decided on Omicron. Honestly, ladies and gentlemen, I don't really know where Omicron, like I don't know how you go from Xi to Omicron, but apparently they did. So how is the Omicron strain different from the Delta strain? Well, there's a lot we don't know. And one thing I will say is this particular strain, this particular virus, has around 50 mutations. Now, I know that the news is saying 37 or 30 mutations. There's a really big distinction here because they are accurate in that there are 30 mutations, between 33 and 37 mutations to the spike proteins on the outside of the virus, and the spike proteins are the structures on the virus that allow the virus to bind to a receptor and enter a cell. But in total, there's about 50 mutations in the entire genome of Omicron. And these mutations all are very interesting. Some of them we don't really know what they do, but others have, play vital roles in cell entry, as the 37 do that contribute to mutated spike proteins, but some others still code for a unique RDRP that the virus brings with it, and stuff like that. So in total, there's around 50 mutations, and the concern here is almost a vast majority of these mutations are what are called mutations of concern, in that they are mutations that could theoretically increase virulency, increase the ease of spread, increase any number of things about the virus. And what we do know currently is that compared to Delta, Omicron-O does spread much more easily than Delta, and it spreads faster than Delta does. Now, why that is, I don't really think we know at this point why it's spreading faster, but it is. And as for, I was reading an article yesterday, I think it was from CNN, or some other news source like that. I don't want to name any names. And they were saying how Omicron is more severe. As of this moment, there is no evidence to suggest that Omicron is more deadly or more severe than Delta was. It's just, the main thing is that it spreads faster than Delta did. And that is the main difference between Delta and Omicron. And frankly, ladies and gentlemen, I know a lot of you scientists are going to be asking me, well, why don't we know this? And the simple fact is there's just not enough data that we have currently. In the intro, I gave you guys a list of all the countries that have it, but none of those countries were above 50 cases. I think the highest on that list was 22 cases of Omicron. And so there's not enough data yet to tell us whether or not Omicron is more deadly than its cousin, Delta. And there's not that much data yet to show what is actually going to be the result of it. But the reason why you have countries, and again, I don't want to name any names, but you have two big Western countries, particular, that have imposed new restrictions on travel and whatnot, and shut down their borders. And the reason for that is because Omicron spreads faster than Delta. And I think at this moment in time, a lot of people are tired of mask mandates, right? They're tired of quarantining. They're tired of SARS-CoV-2. They're tired of COVID, and that's completely understandable. And if, ladies and gentlemen, this is a science podcast, and so we talk about everything science-based, no matter what it is. So if you guys ever want to hear an episode about, the science of how lockdowns have increased depression rates or anxiety in people, let me know. You can always send me an email at thesciencebt@gmail.com. But to continue, ultimately, as far as this moment in time, the main thing that we know for sure about Omicron-O is that it spreads faster than the Delta strain. Now, the next topic I think is one of the bigger topics on everybody's mind. How does it respond to vaccinations? Because again, I was reading the Wall Street Journal today, and I was looking at CNN and all these other news sources, and everyone had their own different take on this. But all of them came to the same rough conclusion that vaccines will either be ineffective or won't really work that well against Omicron. And I want to talk to you guys about why that is. The simple reason is because the way the SARS-CoV-2 vaccine works is it's something called an mRNA vaccine, which is a piece of viral mRNA that is packaged inside a little soap bubble, you could think of. It's not really a soap bubble, but it's called a lipid envelope. But you could think of it as a soap bubble because functionally they're the same thing. And so what happens is this soap bubble gets ingested by the cells in your body, and the cells begin making or producing this mRNA. Now, the key thing here is the mRNA that is put in this vaccine is not the entirety of the virus's genome. It is only a portion of mRNA that encodes for the virus's spike proteins. So what happens? Well, the cell translates that mRNA to produce the spike proteins. Spike proteins are displayed on the surface of the cell, and the immune system recognizes those spike proteins, right? The problem is that Omicron-O, as we said previously, has between 33 and 37 mutations in these spike proteins. So the ability of your so basically then that means that the relatedness of the spike proteins in Omicron to the spike proteins in Delta are quite different. And it's not that nobody knows 100% whether or not vaccines will be effective for Omicron. But what scientists are saying is that they're assuming that they wouldn't be as effective or may even be ineffective because the spike proteins have changed so much. However, there are still regions on the spike proteins that are conserved. They're conserved elements, and it's particularly the part of the spike protein that directly binds to the receptor, which in this case is ACE2. That part hasn't really changed, but it's a very, very small part of that spike protein, the active site, as it's called, is a very, very small part of that spike protein. And that really hasn't changed that much in Omicron compared to Delta. But the rest of the spike protein has changed. The reason for this is if you change the shape of that active site too much, the virus runs the risk of no longer being able to bind to ACE2, and then the virus wouldn't be able to enter the cell. So that is why everybody is saying that vaccines may not be effective against Omicron, and why you have companies like Pfizer, like Moderna. That's why you have those two companies starting to produce new mRNA vaccines, because there's so many mutations in those spike proteins that people aren't really sure if the vaccines will be as effective still. Had to take another sip of my coffee there. And that concludes 2 out of the 3 things I wanted to talk to you guys about today. The third thing is something that always comes up in conversations when I talk to people about this, and when I see conversations that people have about this in the media, in day-to-day life, which is, where did this come from? So we know this came from South Africa, right? But where? Because this virus, or this strain, is very interesting. Because of these 57 mutations, it doesn't really have any direct linkage to any other currently circulating strain of SARS-CoV-2. So, now hold on, before all of you guys start going and saying, it's confirmed it was lab created. No. The ongoing theory of where Omicron-O came from is from an immunocompromised patient. Now, what does that mean? SARS-CoV-2, like other coronaviruses and like a lot of other diseases in general, can form chronic infections in individuals who don't have that good of immune systems, or immunosuppressed patients. Now, generally in immunocompetent patients, or people who are young and healthy and have really strong immune systems, COVID isn't that big of an issue for them. In certain instances, it can hospitalize you, but it's generally an acute illness, which is an illness that I believe the actual term is lasts less than a month. But in patients who have suppressed immune systems, the SARS-CoV-2 virus can form a chronic disease which can last for months. The ongoing theory is that Omicron-O came from an immunosuppressed patient in South Africa. And the reason is because what most likely happened is, inside that immunosuppressed patient, that virus that infected him or her, whoever that patient was, created a chronic infection. And that allowed that virus to keep reinfecting cells in the same host and acquire a myriad of mutations that we see now, and then it was spread from the index patient, or patient 0, if you will, to the next person and the next person. And that's the most likely place where that virus acquired these 50 plus mutations. So it was not created in a lab, but it was created in the lab that is the human body. And ladies and gentlemen, I know this was a longer episode, but I think I kind of owe you guys something after my flaky upload schedule. Ladies and gentlemen, after this episode ends, I think the big takeaway from this is something that extends past Omicron and SARS-CoV-2, which is just how amazing the human body actually is. And how amazing that we are bombarded by pathogenic threats every day. And yet, for the most part, our bodies are able to defend themselves from these pathogenic threats. And to me, as a young prospective doctor and as a microbiologist, that is something that, that is something that gives me shivers and gives me a reason to get up in the morning. So nonetheless, thank you, ladies and gentlemen, for listening to today's episode. I hope you have a happy Friday. Woohoo, it's Friday. And I hope you guys enjoy that cup of coffee. I will see you again on Monday. And remember, ladies and gentlemen, as always, stand up and question everything.